have 4 hours to live. You just don't know it yet. Somewhere off the coast, the water is pulling back. Not like a tide, not like anything anyone alive has ever seen. Boats are settling into wet sand instead of water. Fish are stranded on ground that was ocean floor an hour ago. And nobody standing on that beach understands what they're actually looking at. They think it's a strange low tide. Some of them are filming it, laughing, walking out to grab fish off the ground. That's the part that should unsettle you. The most dangerous moments in human history rarely look dangerous while they're happening. What they're witnessing isn't the ocean leaving. It's the ocean pulling back its arm before it swings. Now imagine something stranger. Not a wave, not a tsunami warning. Imagine the ocean simply not coming back. Overnight, 70% of this planet's surface empties out completely. Not evaporated, not boiled. All happened to you, wherever you're sitting right now. Most people picture the same thing. Dry seabeds, dead coral, maybe a few sunken ships lying exposed in the dust. It sounds almost peaceful, a quiet apocalypse. It wouldn't be quiet at all. And it wouldn't start with fish. It would start with the ground itself. Here's the part almost nobody thinks about. The ocean isn't just water sitting on top of the planet. It's weight. Immense, constant weight. Pressing down on the crust of the earth the way a hand holds a lid on a pot that wants to boil over. Take that weight away in an instant, and the crust doesn't just sit there, exposed and calm. It reacts. Scientists call this general effect isostatic rebound, the same process that's slowly lifting land in places like Scandinavia today, thousands of years after ancient glaciers melted off it. That took centuries. In this thought experiment, it wouldn't. Picture the tons of pressure, starting to crack and shift almost immediately. Fault lines that have stayed silent for millions of years would have nothing left holding them still. And a fault line with nothing holding it still doesn't ease into motion. It snaps. In this scenario, the first few hours could bring some of the most violent earthquakes imaginable. Not along the coasts people know, but underneath land that used to be seafloor. And that's before anyone even mentions the volcanoes. There are more volcanoes hidden beneath the ocean than anywhere else on Earth. Most have spent their entire existence held in check by staggering water pressure, similar to how your ears feel a shift on an airplane, except multiplied thousands of times over. Pull that pressure away all at once, and you're not looking at a handful of eruptions. You're looking at the possibility of a chain reaction, magma finding cracks that have never once touched open air. And somewhere in the middle of all this, something quieter starts happening, something almost personal. Because the ocean isn't just geography, it's temperature control. It behaves like the planet's thermostat, absorbing most of the extra heat trapped in the atmosphere and slowly spreading it around the globe through currents most people never think twice about. Take that thermostat away, and heat has nowhere left to go. Regions that were once mild could turn brutal. Places that depended on ocean-driven rainfall could dry out in days instead of decades. The air itself would feel different, heavier, wrong. Here's where it gets strange in a way that has nothing to do with geology. It's about you. Because somewhere in your mind right now, a small part of you is picturing standing on that empty seabed, walking into a space that was always out of reach. And there's something in that image that doesn't feel like fear. It feels closer to curiosity. There's a name for that pull. Some researchers call it the allure of the forbidden view. The same instinct that slows drivers down at a car accident or draws your eyes into a dark hallway. Humans are wired to lean toward revealed secrets, even dangerous ones, because for most of human history, seeing something hidden meant gaining an edge. Your brain doesn't know the seafloor is unstable, it just knows it's new. And to a mind shaped by evolution, new has almost always meant opportunity. That instinct is exactly what could get people killed in this scenario. Because while some part of the crowd is drawn toward the exposed seabed out of pure disbelief, the ground underneath them is still absorbing the shock of losing billions of tons of pressure in an instant. Disaster researchers find this gap the most disturbing part of any sudden coastal event. Not the danger itself, the distance between how fast a threat moves and how slowly the human mind processes something it has never seen before. It's called normalcy bias, the mind's habit of explaining an unprecedented event using ordinary language, because ordinary language feels safer than the truth. A wall of water becomes a strange tide. A collapsing seabed becomes an interesting sight. Faced with something outside its experience, the brain doesn't panic first. It rationalizes first. So picture it differently now. Not as a distant disaster, as something happening to you. You're standing somewhere ordinary. A kitchen, a car, a street you've walked 1,000 times. And somewhere, thousands of miles away, the pressure that has quietly held this planet together for millions of years disappears in an instant. You wouldn't feel it first as water. You'd feel it as ground. A tremor beneath your feet with no obvious source, because the fault line behind it sits underneath something that used to be unreachable. That's the part worth sitting with. We treat the ocean like scenery. something to glance at on vacation then forget. But in this thought experiment, it's revealed as something else entirely, one of the few things quietly keeping the ground beneath your feet exactly where it currently is. Every earthquake that hasn't happened yet, every eruption still asleep below the surface, every summer that isn't 10 degrees hotter than it should be, all of it held in place by something you've spent your whole life barely noticing. And maybe that's the real unsettling part of this whole idea. Not the wave, not the fault lines, not even the heat. It's the realization that the most dangerous kind of stability is the kind you never think to question. The kind that feels permanent, right up until the moment it isn't. So the next time you're standing at the edge of something vast and quiet and seemingly still, ask yourself what's actually holding it there, because chances are you stopped noticing a long time ago.